All right, this is going to be the second video for Notes 79. You can see the first part. I did this in the first video. So this was all simplifying and evaluating up top and then applying the properties of logs to question number 2. So if I slide on down to question number 3, we are solving some more. So let's start with question number 3, part A here. What I want to do is take this log, and it's an equation, so I'm going to rewrite it into exponential form. So I've got a base 2. The log is equal to the exponent, so 2 to the 4th equals the argument here of x plus 3. Well, all right, cool. While it's an exponential problem, I can solve this. This is just a number. Let's see, 2 to the 4th would be 16. X plus 3. All right, good. We're working here. Let's go ahead and subtract 3 from both sides. So 13 is equal to x except for one thing. All right, it's a small thing. Actually, no, it's not a small thing. But what we have to do is once we take a look at this answer, right, we've got a value for x. What I need to do is make sure that whatever this value is, that when I put it back into this argument for a logarithm must be positive. It has to stay positive, must be positive at all times. So if I go with 13 here and I pop it back in here, well, 13 plus 3 is 16. Yeah, 16 is a positive number. We are good to go. So we have an answer here, all right? And it's happy to see you. All right, so sliding on over to part B here, I can do the same thing, right? It's the same kind of setup. So we've got, let's see, base 4 here raised to a power of 2 if we turn it into exponential. So 4 squared equals x minus 8. So again, while it's turned into exponential, because the exponent is numeric, I can simplify this. 4 squared is 16. This is equal to x minus 8. If I then want to solve for x, I'm going to add 8 to both sides. So x is equal to, what is that, 24? Yeah, it's 24. And again, quick double check. Take 24, pop it back up in here. And yeah, 24 minus 8 is a positive number still. So that's awesome. I like my answer. And hey, look, that one's happy to see you too. All right, so if I slide on down to part C, now this one's a little different. Right, in question part B, we had a log equal to a number. Okay, that's fine. So we simplified this one. Same thing with part A. You know, we had a log equal to a number. All right. Part C here, I have a log equal to a log. Well, okay, let's make sure of one thing. This is a log base 5. This is a log base 5. Ooh, I like this. Because these logs are identical, folks, all you got to do is set the arguments equal to each other. All right, this is the same type of question as when we basically, let me see if I can find one of the last problems. Oh, I can, right here. Right, when we rewrote 3 to the x equals 9 and we transformed it into 3 to the x equals 3 to the second, we're like, oh, okay, so these bases are the same, which means these exponents have to be the same. It's the same concept, absolutely the same concept, all right? So as long as your logs are identical, which log 5 and log 5 are identical, clearly, then this argument and this argument will have to be equal. So we're going to make an equation here with just those arguments. The logs are completely gone, right? We don't have to pay attention to them. We just have to solve this. All right, so this equation is an no, it's not exponential. What am I talking about? It is linear. It's a linear equation. So to solve a linear equation, I'm going to get x to one side. So I'm going to subtract 2x. And at the same time, I move the constant to the other side. I'm going to go ahead and add 8 to both sides. All right, because those have nothing to do with each other, I feel comfortable doing those at the same time. So 4x minus 2x is 2x. Negative 8 plus 8 is done. 2x minus 2x is done. And 4 plus 8 makes 12. So to finish this, let's go ahead and divide both sides by 2. And I'm getting x is equal to 6. But we still do need to double check because I do have logs on both sides. I want to make sure that this 6 is good to keep both of these expressions positive. So if I double check, let's go ahead and pop a 6 up in here. Let's see, 4 times 6 would be 24. 24 minus 8 is still positive. And I don't really care what the positive number is as long as it's positive. And let's see, 2 times 6 is 12. 12 plus 4, definitely a positive number. All right, so after all that hard work, we have a value for x, and it is good. All right, this is the end of Notes 79. As always, please let me know if you have any questions or concerns, and I will see you in the next one.